right, we're going to talk about scientific notation. It is a way of showing numbers using exponents, and it's an 8th grade standard for Minnesota. So scientific notation, we like to translate numbers. Scientific notation is a shorthand. It's a quick way of writing really big numbers, so really large numbers, or really small numbers. A lot of times we do use this in science, especially like astronomy, when we're dealing with millions and billions of miles away, or we're dealing with atoms, so super microscopic numbers. So that's when we a lot of times use scientific notation, hence why it's called scientific. So in order to use scientific notation, we need to review our powers of 10, because scientific is dealing with powers of 10. So just really quick, 10 to the second means 10 times 10, which is 100. 10 to the third means 10 times 10 times 10, which is 1,000. 10 to the fourth is 10 repeated 4 times, so 10,000. And 10 to the fifth is 10 multiplied 5 times, repeated, which is 100,000. So that's for our really big numbers. Our really small numbers would have a negative in the exponent. 10 to the negative 1/2 is 1 over 10 to the first, which is 1/10. 10 to the negative 2 is 1 over 10 times 10, which is 1/100th. 10 to the negative third is 1 over 10 times 10 times 10, which is 1 over 1,000, which is 0.00, which is 1,000th. And last but not least, 1 over 10 times 10 times 10, which is 1 over 10,000, which is 1/10,000th. So there we go. So those are just kind of our reviews of powers of 10. So what scientific notation is it's taking a digit and it's multiplying it by a power of 10, either a very large power of 10 or a very small power of 10. So what this looks like, number one, 3 times 10 to the third. That's really just saying 3 times, well, 10 to the third is 1,000. So that is 3,000. So 3 times 10 to the third is just saying 3,000. Number 2, 7 times 10 to the ninth. If I have to write that one, that is, well, here we go. That's 9 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 7 times, what is that, a billion, which would be 7 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, it's a lot quicker to write that than it is to write that. Here we go, 4.1 times 10 to the fifth. 10 to the fifth is 1 with 5 zeros behind it. And so that is, how do I do that? Well, really, all I'm just going to do is 3, 4, 5. Nope, that's not right. What did I just do? There we go, 410,000. Alrighty, now let's do some really small numbers. This is saying 3 times 0, 0, 1. And what do we do here? That is 0.003. Fun. Oh no, now I have a whole lot of these. Okay, this is 7 times, oh goodness gracious. 1, 2, 3. I even forgot my zeros. 1, 2, 3, 4. 9. Which is how many zeros am I at? I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, another proof of it is a lot easier to write scientific notation than it is to write it in standard form. And then this one would be 4.1 times 0.0 0.008. And how in the world would we do this? Well, basically we're taking 4.1 and we're going to move it 5 places this way. So 1, 2, 3, 4, 5. That's where my decimal goes. And I'm going to fill in zeros at each of these places here. So I'm going to get 0.1234, 1, 2, 3, 4, and then my 4, 1. That's a lot of zeros. So how does the exponent affect your final answer, your final product? It's going to give you a really big or a really small number. A negative exponent is going to give you a very small number because it's moving your decimal point to the left. Your exponent, and then a positive is going to give you a really large number. Your exponent tells you how many places I'm going to move my decimal. If you can move your decimal, you can do scientific notation. So here are your basic notes for scientific notation. Your first number right here needs to be a number that is greater than or equal to 1, but it has to be less than 10. So this number here has to be a 1 point something up to a 9 point something. You cannot have a 0 here or a 10 here. This leading digit has to be a 1 or a 9. So 1 to 9. And then you're going to multiply that by some power of 10. 10 to the second, 10 to the 12th, 10 to the negative third. If this exponent, the bigger this exponent, obviously the bigger your number. If this exponent is a negative, that means you have a very small number. So that is your basis for scientific notation. This number has to be in between 1 and 10, not including 10, times some power of 10. Let's go ahead and practice turning things from standard form into scientific notation. So here we go. I have a really big number here, 8,410,000. That is written in what we call standard form. Standard form is just what we normally write it as. But we want to convert it into scientific notation. I want to write it as a number times a power of 10. So I need to decide where I'm going to move my decimal in order to have a number that's greater than or equal to 1, but less than 10. So here would be my imaginary decimal. I'm going to move it over 1, 2, 3, 4, 5, 6 spaces. So my number, my leading number, is going to be, 1 digit. You're going to have 1 digit before the decimal, and I'm moving it over 6 places. So count how many spots I moved it. I'm moving it over 6 places. So I can put my number here. And this tells me my exponent. The number of spots that I move my decimal tells me my exponent. Now I'm going to go ahead and write it as a power of 10. So my leading digit is 8.41, right? That I have 1 digit in front of my decimal point, and it's times 10 to the 6 because I moved my decimal point over 6 spots. I know this is a positive exponent because I started with such a large number. The larger the number, the positive the exponent. Now let's deal with a really, really small number, 0.0078. This is written in standard form, just how we would normally write a decimal. Now I want to convert it into scientific notation. First thing I need to do is where am I going to put my decimal in order to have a number greater than 1 but less than 10, and that means it's going to have 1 digit before the decimal, and so my decimal will end up being right here. So I can have 7.8. Now I'm going to count how many spots I move my decimal. My decimal started off, my decimal started off right here. It was 0.0078, and I'm going to move it over 1, 2, 3 spots. So I move it over 3 spots. That's going to tell me what my exponent is. Now I'm going to go ahead and write it in scientific notation. My number is going to be 7.8. That's bigger than 1, less than 10. Times 10 to the, and my exponent is 3, and I know it's actually going to be a negative 3. I know it's a negative exponent because we started off with such a small number, a number that was less than 1. So that tells me my exponent's going to be a negative. So let's go ahead and do this practice converting standard form into scientific notation and scientific notation back into standard form. I'll go ahead and do the first 2 examples and then give you a chance to do those. So scientific notation, I'm basically going to move my decimal over 1, 2, 3, 4, 5 places, and that is going to be 3 times 10 to the, and that is a negative 5 exponent because I have a very, very small number that I'm converting. And if I want to go from scientific back to standard, well, I know I'm going to basically be moving my decimal 8 places because my decimal is 8. So I have 8. And then this is a positive exponent, so I know I'm going to have a very, very large number. So I'm going to add 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then add my commas. And so that's 800,000. Go ahead and work on the rest of these. I will give it a pause and then I will go ahead and fill these in. A lot of times when I'm going from scientific notation back to standard form, I'll go ahead and write my, my standard form decimal, and then I'm like, all right, which way am I going to move my, and I'll just do my little placeholders and then fill them in with zeros. I find that's easier. That's just my personal opinion. And then here, I know I'm going to move it over 5 spaces. 1, 2, 3, 4, 5. Got to add a 0. So that becomes 4, 6. And then, boop. This one, I'm going to start, I know it's a negative, so I'm going to have a very small number. I'm going to be adding zeros to this side, so I'm going to start over here, right, 1.1, and then I'm just going to move my decimal place over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's where my decimal is going to be. I'm adding a whole lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that makes sense that I would have 10 zeros because I have this 1 here taking up the 11th spot. So if I were to rewrite this, it would be 0. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 1. Biggest mistake that you can make is just not counting a 0 because we get lost with our zeros, which is the entire point of having scientific notation. This one I have 12. I already have 2 spaces that are going to count for those 12 spaces that I need to move it over, which means I'm going to be adding 10 zeros. So 2, 0, 8, and 10 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then add my commas. 1, 2, 3, comma. Oh, that's a nice one. Nice big number. Let's see. 1, 2, 3, 4. I know that I'm going to be moving my decimal over 7 places, right? And my decimal starts here. 3, I'm going to be moving, is already a placeholder, and so I need to add 6 more zeros to make 7 places that I move it over total. So I have 1, 2, 3, 4, 5, 6, and then that 3. And that brings me to 1, 2, 3, 4, 5, 6, 7 places.